Hi Andrew, how are you?
I'm good, thank you. How are you?
Good, good. So, yeah, today we'll be covering the VLAN and its applications. All right, so let's start. All right, so in here you will be having three hands-on exercise. The first one you'll be configure multiple wireless VLANs and multiple subnets on a figure an AP3. And
Yep.
then you will be creating the tactic VLAN, the X02.1Q tactic VLANs between a 2065 LAC and a P1282 switch, which is I believe is on your desk right now. And then the last bit will be the we'll be using the central switch management in the DrayTek router to creating the tactic VLAN between a 2927 and the figure switch. All right. So we'll be start by covering some theory and look at the topics that we listed here in the outline. So what is freelance? Why do we need to use freelance? And what are the two types of freelance that our DrayTek routers offer? We compare and outline the two types of freelance, which is the port-based freelance and the tag-based freelance. We will go through a little bit about how you can enable interland routing between the different subnets,
Yep.
and we will go over some real life example that you can utilize freelance. And then we will start by working on our first hands-on exercise. And then after that, we will cover a little bit of freelance configuration in the figure switch. Hopefully, we will still have time to do two more hands-on exercise in the with the figure switch. All right.
Sure.
So, what is VLAN and why do we need to use freelance? So in here, I have a definition of freelance, which it says a virtual local area network is a logical group of workstations, servers, and network devices that appear to be on the same LAN despite their geographical dispersion. So in other words, is that a VLAN is a group of devices that are physically on the same LAN, but separate by using the information in the Ethernet packets, and they don't necessarily have to be together in one places. So the VLAN information is in the layer 2 header of an Ethernet packet, and it is a 12 bits of data between the type and source MAC address sessions on the Ethernet packet. And okay. So using VLANs allows you to segregate your network and prevent devices in one part of the network from getting access to the other part of the network and vice versa. VLANs allows you to segment your network by function or applications. Unicast, broadcast, and multicast packets are forwarded to the port that belongs to the same VLAN. This will enhance the network performance since the broadcast and the multicast packets are not sent to the other part of the network. VLAN can also ease network configuration by logically grouping devices without physically relocating them. So in here, we have a diagram. We have a typical applications of VLANs in this diagram. We have 4 local area networks here: the administration, the sales department, the support department, and the warehouse. So the devices in each of these LANs could be in a different location within the building, but they are logically part of the same network. So why do they need to use VLANs? So if you are looking after some large networks that may include IP cameras, IP phones, and so on in addition to your PC data network, you will find that if all of these devices are installed in a flat network, sooner or later you will see network congestion. You result and see the slow network response times and poor phone call quality. And the solution is to separate all of these services by using VLANs. One of the benefits of using VLANs is that it can increase the number of broadcast domains. This will reduce the network congestion and improving the network performance. VLAN can also be used to create logical groups and allow communications between the required subnets. Firewall rules can also be used to control the data flow between the networks when the routing is enabled. This will increase the network security and minimize external threats. So imagine an attacker from outside your network gain access to one of these VLANs. They will be contained to that specific network by the boundaries and controls you put in place to prevent them getting access to another network. Also, VLANs are not restricted to one switch. They can extend across multiple switches, and this will increase the flexibility to the network. Um, Grouping is logical here, it's not physical. So let's say within a building, we have a sales department on the first floor, but one of the salesperson is also working on the second floor within the company. So no matter where the salesperson PC or devices is placed in the building, it can still be part of the sales VLAN. So now let's talk about the advantages. VLANs helps to make network administration much easier by logically grouping users into the same virtual network. It will be easy to control and set up your policy at a group level. So when a user physically moving workstations, you can still keep them on the same network with different equipment. Troubleshooting network problems can be simpler and faster when different user groups are isolated from each other. If you know that complaints are coming from a certain subnet of users, you will be able to narrow down and resolve the issue quickly. VLAN can also improve the quality of service by managing the traffic more efficiently so that end users experience better performance. There will be less latency problems on the network and improve the reliability for critical applications. VLAN can also be used to prioritize traffic, and this will make sure the data keeps flowing on critical applications, even though when lower priority traffic congestion, like web browsing spikes. All right, so the first quiz of this session, why would you use VLANs in the network?
It's all of the above.
Yes, that's correct, Andrew. All right, so the next session will be we'll talk about the types of VLANs DrayTek routers offer. So the two main types are the port-based VLANs and the tag-based VLANs. So the first one we'll be looking at is the port-based VLANs. As shown in this diagram here, you can see the VLANs are assigned to the LAN port on the router. So any devices plugged into one of these ports will be part of that VLAN. So in here, you can see that we have VLAN 0 for sales, VLAN 1 for admin, and VLAN 2 for the guest Wi-Fi. So each of these work groups will be isolated from each other, but they can still access the same internet connection. So for example, if I plug in my device to, let's say, port 6 here, which it will obviously belongs to the VLAN 1 admin department. The next type will be the X02.1Q tag-based VLAN. In this case, the VLAN is not tied to any particular port in the router, but instead it identified by a tag called VLAN ID. The VLAN ID is limited by 12 bits or 2 to the power 12, which gives a maximum limit of 4096. The actual number of VLANs that can be configured in the DrayTek switch will be limited by the router model or the switch model, and it would usually between 2 to 50 VLANs. So if the VLANs are not tied to any particular ports, so how do we do the VLAN, set up the VLANs? So now we need to set up a single port on the router, configure with multiple VLANs in here, which also contains a VLAN tag, and this is called the VLAN trunk connection. And then we would connect it to a managed switch. So in this example here, we have 3 different VLANs. in the VLAN trunk connection and connect to the switch. And these different VLANs can be used for different work groups. So as I've mentioned before, the VLAN tag is in the data packet header, which is used to identify the VLAN it belongs to. And another parameter in the VLAN tag is the 802.1p settings. And this is used to specify the priority level for the data packets. And it ranges from 0 for the best effort to 7 being the highest level. So you can see it, 0 to 7. Another quick quiz. So what are two types of VLANs used in DrayTek routers?
Tag and port
But
based.
right, that's right. And what are the differences between this port-based and tag-based VLAN?
The port based is based on individual ports. It's pretty self-explanatory. The tag
Yeah.
base is put into the IP header.
I had with the VLAN ID. Yeah, that's right.
Yeah, the VLAN
So
ID. Yeah.
right. So the port-based VLANs is the VLANs are assigned to the LAN port on the router, and the tag-based VLANs is a single port on the router configured with multiple VLANs, which also contain a VLAN tag. Right. So if you want to allow communications between each VLAN, then you will need to use the interLAN routing feature in our DrayTek routers, and it is fairly simple. You just need to enable a tick between the required subnet, but will have a go later. I just quickly explain about how you can do that. So in here, we just want to allow communications between the administration work group and the sales department. So we can simply just enable the interLAN routing between these two subnet, and that's it. Just yeah. I'll show you how to do that in a moment. And right now we will look at some typical scenarios that we can use freelance. And this type of example, we got it from our clients and from the past experience. Scenario one, let's assume a company wants to separate the employees' Wi-Fi and guest Wi-Fi to restrict access of guest user only to the internet. Other LAN resources like server, online portal, printer, and so on should not be accessible to the guests. So in here, we will define two VLANs, which can be VLAN 1 and VLAN 2. And the subnet of the VLAN 1 is 192.168.1.0, and the subnet of VLAN 2 is 10.0.0.0. And of course, we don't want to enable interLAN routing in this case. Right. So another scenario is that we have 4 companies that are located in the same building, and they share the same broadband network and use a DrayTek router for load balancing, security, and VoIP features. So to keep all the companies separate but still can share the same internet connection, we can create 4 VLANs in the network. Let's call them VLAN 5, VLAN 6, VLAN 7, and VLAN 8, and each of them has a different subnet. And of course, in this time, we don't want to enable interLAN routing, of course. Another example where we can use the VLAN is to adding the VLAN tag for the WAN connection. This is set up in the WAN and general setup configuration menu in the DrayOS router. So so for this VLAN, we put it on the WAN connection because some of the ISP in Australia requires a VLAN tag to get the internet connection. Otherwise, if you don't put the VLAN tag, there will be no data connection at all. So in the diagram above, we show the common VLAN tag in Australia. Usually is the number 100. For TPG, it uses 2 or 100. For Telstra fiber, I believe there's a requirement to use VLAN tag 101 or something. And the diagram above, below will be the common VLAN tag for the service provider in New Zealand, which is VLAN tag 10. All right. So this example is a little bit more complicated. I'll explain a little bit more slower. So we encounter a situation that the end users would like to replace his ISP router with a DrayTek because the DrayTek routers provide more features he wants to use. So, however, the ISP supply router has a built-in ATA feature for the VoIP services. So most of the time, you can't just replace the ISP router with the DrayTek because the SIP details are locked into that ISP router. So in this example here, the ISP router also requires a VLAN tag of 10 to use the phone services. So in a situation like this, you will see there are two routers in line. You can see the DrayTek routers in the front, which provide the internet connection for the entire network behind it. And then there's a VLAN tag of 10 will assign on the WAN side for the internet connection. Then there is a VLAN tag of 10 assigned on the LAN side, which provides to the ISP router for the VoIP services. So this is the screenshot that the customer set up the VLAN tag 10 on the LAN side, which pass it to the ISP router behind it. So in here you can see that for VLAN 0, we set it up as a untagged VLAN. You configure the port 1 to port 3 to there, and then all the SSID. But specifically for VLAN 1, we put port 4 and a VLAN tag of 10. So you can connect a Ethernet cable from the DrayTek router port 4 to the WAN port on the ISP router behind it. So now I will show you how to do the VLAN configuration steps in the DrayOS router. Let's start by looking at the port-based VLANs. This applies to all the DrayOS routers, such as the 2065 or the 2927 that is on your desk here. And the steps involved here is also covered in our knowledge base article. So yeah, just in case you need more information, you can go there anytime. Okay, all right. So let's go to, if we want to enable the VLAN, we go to LAN and then VLAN configuration and select enable. The next step is to assign all the ports and SSID to a VLAN. You can select a LAN subnet for the VLAN for each individual VLAN in the circle here. Make sure you assign all the LAN ports and SSID to a VLAN, because on some older firmware you need to do that to save the settings. But I believe in the latest firmware you don't have to assign all of them. But we always recommend to do that because it will have less confusion when we're trying to troubleshoot the issue, stuff like that. And yeah, and the number of ports shown here, you see here, P1 to P5, and the LAN subnet in here vary by the router model. If you are familiar with the 2062, you will notice there are port 1 to port 6, but I believe on the 2065 there is only port 1 to port 5. So I remember. Right. So okay. Oh yeah, that's one more thing. You don't want to enable VLAN text for the port-based VLAN. Otherwise, it won't work. Okay, so the next step is to enter the LAN details, the LAN subnet details for each of these individual LAN, including the DHCP server details. Right, here is where you can allow communications between the two VLANs. So in this example here, we would like to enable communications between the LAN 2 and LAN 3 subnet, so we can simply just take it in between the intersection. Right. So I'm not sure if you are familiar with this, but the 2065 and 2927 that you work on the last 2 days is running the DrayOS software. But we have some older models which is running the Linux-based software, such as the 3910, 3900, and the 2960. And yeah, the first step is to create the VLANs, and then we assign to the LAN port as untagged. You can see it here. The next step is to configure the LAN subnets for each VLAN. In the example here, we have assigned subnet 192.168.50.1 to VLAN 100. In the Linux router, we only have a global options to enable interLAN routing. To do that, we just simply go to the interLAN route page and select the enable interLAN route. Next to it, we have a route group using route group features. You can use this to allow or block routing between the VLANs. Of course, you can also use firewall rules to do that. To set up the tag-based VLAN in the DrayTek router is similar to setting up the port-based VLAN, but it just includes a couple more steps. The first step, obviously, is go to LAN, VLAN, and then enable the VLAN configuration. Assign all the ports and SSID to VLAN, and then the next step is to enable the VLAN tag. The priority level here is optional. 0 is the lowest priority, and 7 is the highest. And it is also recommend to select the permit untagged devices in P1. The reason for doing this is that usually we will have a switch between the router and the computer, and the switch will handle the tagged data packets. But for some reason, if you want to connect your, let's say your laptop directly to the router for troubleshooting, you won't be able to get to the web management page unless you do this option. So you can do that to connect your laptop to P1 and get to the web interface management page. All right, the next step is to set up the LAN subnet details. Enable the interLAN routing if required. In the Linux-based router, you need to select a VLAN for a member to become a tagged VLAN. So in here, we have selected LAN port 2 to become a member of VLAN ID 30. Now is to select a trunk port on the DrayTek router. So simply, you just select all the VLANs to the same LAN port, and yeah, that's it. And it's quite simple. And for the Linux-based router, you add the VLAN ID to a single LAN port. In here, we add VLAN ID 10, 100, 123, 20, and 30 to LAN port 2. So this diagram is a typical applications that utilize the 802.1q trunk. A switch is connected to the router with a 802.1q trunk port, and then the network behind it will connect to an individual segment on the switch that has a different VLAN tag, VLAN subnet. So here we have a short video showing how to configure the VLAN on an access point, and then we connect it to the DrayTek router using the 802.1q VLAN trunk. Our next exercise will be similar to this video, so if you could drop down some notes, then it will be faster to do the next exercise. All right. In this video, we will demonstrate how to configure multiple IP subnets and VLANs in the Figure 2865 LAC. We will then use the same VLANs in the Figure AP903 by setting up an 802.1q VLAN trunk between two devices. Now let's log into the Figure 2865 LAC router and configure the VLANs. Log into the router using the IP address 192.168.1.1. Go to LAN, VLAN, VLAN configuration. We will configure LAN port 5 as the 802.1q VLAN trunk port and select all the VLANs for this port. LAN 1 will be the management LAN and will not have VLAN tag enabled. This will allow us to access the router. LAN 2 will have a VLAN tag ID 100. LAN 3 will have a VLAN ID 200. Finally, LAN 4 will have a VLAN ID 300. Click OK to complete the VLAN configuration. Go to LAN, General Setup, Configuration menu, and configure each LAN. Click on Details page on LAN 1 and enter the IP address 192.168.1.1. The start IP address is 192.168.1.10 and the gateway IP address is 192.168.1.1. Next, click on Details page button on LAN 2 and enter the IP address 192.168.2.1. The starting IP address is 192.168.2.10 and the gateway IP address is 192.168.2.1. Next, click on Details page button on LAN 3 and enter the IP address 192.168.3.1. The starting IP address is 192.168.3.10 and the gateway IP address is 192.168.3.1. Finally, click on the Details page button on LAN 4 and enter the IP address 192.168.4.1. The starting IP address is 192.168.4.10 and the gateway IP address is 192.168.4.1. Now connect your device to P1 port on the AP903. To connect the AP903, first configure your PC with a static IP address. In here we use 192.168.1.30. The subnet mask is 255.255.255.0 and the gateway is 192.168.1.1. Log into the Vega AP903 using IP address 192.168.1.2. The default username and password is admin. The operation mode in the access point will need to be selected as an AP mode. Click OK to apply the setting. After that, go to LAN, General Setup, and disable DHCP client and the DHCP server. Enter static IP address 192.168.1.2, subnet mask 255.255.255.0. The default gateway is 192.168.1.1. This will make it easier to access the access point management page once it is connected to the router LAN port. Go to Wireless LAN 2.4 GHz, General Setup, enable Wireless LAN and configure the 4 LANs with the corresponding VLAN ID configured in the router. First, configure the first SSID as LAN 1, the second SSID as LAN 2 with VLAN ID 100, the third SSID as LAN 3 with VLAN ID 200, and the fourth SSID as LAN 4 with VLAN ID 300. Click OK to apply the settings. Now, go to Wireless LAN 2.4 GHz, Security, to set up authentication for each SSID. Select SSID, select an authentication mode, select a WPA algorithm, enter passphrase, click OK to save. In here, we quickly configure the same settings for SSID 2, 3, and 4. Now connect router port 5 to figure AP93 port 4 as shown in the diagram. There are a few devices are already connected to the AP93 using the 2.4 GHz wireless LAN. The device list can be found under wireless LAN 2.4 GHz station list. On the first row, a device named Sync is connected to the LAN 1 and obtained an IP address 192.168.1.11. On the second row, a device named User B is connected to the LAN 2 and obtained an IP address 192.168.2.10. On the third row, a device named HP NBHL1 is connected to the LAN 4 and obtained an IP address 192.168.4.10. On the last row, a device named iLAN is connected to the LAN 3 and obtained an IP address 192.168.3.11. This concludes how to configure multiple IP subnets and VLANs in the Vega 2065 LAC and Vega AP93. Thank you for watching. Right, okay. So now we will have a go on our first hands-on, which is similar to the video that you have just watched. Don't worry about it. If you're stuck, we can just always help you out through the solo assist. So do you want to have a go now, Andrew?
Oh.
Yeah. So yeah. Also, we have to mention that the LAN 1 in the video it shows 1.1, but I believe we have set up the 2065 as
9.1.
Yes, that's right. So yeah, just make sure you use .9,
Yeah.
192.168.9 for the access point as well.
Yeah.
So let's say 192.168.2, well, .9.2, yeah, for the access point.
Yeah.
Right. So now we'll talk about the VLANs in the DrayTek switches. You may wonder why do we need the VLAN in the switch? Suppose the router can handle all the VLAN, why do we need to do it on the switch? But actually, in the real world example, in a large network, there are more data traffic between the devices or the servers on the local area network, and not too much traffic going out to the internet. So, for example, the IP cameras store on the local area, NVR, or the iPhone.
NAS or something. Yeah.
Yes, you get the idea. So, like the documents you store on the local PC server, etc. So, if we keep all of this internal traffic out of the router, we can reduce the load on the router, or maybe you can just get a cheaper router instead, and then you can just use the switch to handle all the VLAN type of traffic. Yeah, and the DrayTek figure switches also support the port-based VLANs, just like the router, and as well as the tag-based VLAN, where you can just config a VLAN trunk between the DrayTek router and the DrayTek switch, and then pass along the packets to the switch, and then the switch will do all the monitoring and sending the packets
Packet
to
routing and everything. Yep.
yeah to its belongs network. So all right. So yeah, also worth to mention is that there are 3 more types of VLANs that can be set up in the DrayTek switch, which is the voice and surveillance VLANs, the MAC-based VLANs, and the protocol-based VLANs. And because we are not going into more details here today, so if you are interested, there is more information in the training manual on page 26 to 30. So yeah, if you are interested about these 3 types of VLANs, you can have a look on the menu. Just mark down 26 to 30.
Yep.
All right. Okay. Now we'll talk about the VLAN modes in the DrayTek switches. These are the access mode, which is used for the VLAN unaware device, which is untagged device. The trunk mode will be allow multiple VLANs to be sent over a single connection, which we will do that later also. The hybrid mode will be the combination of the access mode and the track mode. And the tunnel mode is referred to a queue-in-queue trunking. And this is available in our layer 2 switches, which is mainly used by the ISP for their MPLS networks. And if you want to learn more about this one, we also include this in our menu from page 31 to 36. It's a very useful information, but because these are the, if we go into more details, we can go into for more like additional 2 more hours. So we probably will have a workshop talking about the VLAN switch, VLAN in the figure switch in the future. But yeah, in the meantime, please refer to the training menu. So in here, we have a combination of the use for each freelance modes, and yeah, and we will also add this table on the page 30 in the training manual if you want to keep it as a reference. So now we will show you how to the configuration steps used to set up the VLANs in the DrayTek switches. So simply, you just add the VLANs and then select it as a base and port base, and then you assign the VLAN membership for the ports, and you need to set up a trend port, obviously, and then you configure each port which VLANs it belongs to. Now, this is the second hands-on exercise. It probably would take a bit longer than the first one, but we still have time. So this exercise, we will be setting up the H02.1Q VLANs between the 2065 and the figure switch. You can refer to page 57 to 69 for the exercise. There are more details in the training exercise as well. Let's see. Right. Let's see if we need to reset the switch for this exercise. No, you don't need to. All right. So what you need to do is you need to first set up the VLAN on the router. And then you need to enable the Inter-VLAN between all the subnets on the router as well. Yeah. And then we will do the switch part once you've done this. All right, so yeah, this one will be the central switch management, which is similar to the one that we're trying to do, but it'll be easier to do all the step config, the switch stuff like that. So yeah, you can manage the figure switch, and by instead of logging in into each of the individual switch to set up the VLAN. Basically, you can do everything in here, monitor the switch, set up the VLAN, check the groups, maintenance as well, if you want to do that as well. All right.
Yep.
So just quickly, yeah, this is what I just mentioned. You can do the maintenance tasks as well as you monitor the switch, LAN client statics, etc., etc. Right. So yeah, we have a screenshot here, which is one of the configuration page in the central switch management. It will be easier to actually our client say that it will be easier to do this by setting up the VLANs in the switch, and the VLANs can also assign to the switch port, update the router VLAN configuration as well. It can also detect the downtime and uptime. Sorry, the uplink and downlink as well. Yeah, so quickly just go through exercise 3. So if we can go to page 70 in the training menu. Right, so in today's session, we learned that VLANs help to improve the network performance by reducing the congestion, enhancing security, and adding flexibility. VLANs allow a logical group of users by function rather than location. They make it easier to administer the internet, the network. DrayTek routers and switches support port-based and tag-based Obviously, the switches also support additional 3 VLANs, but just and the DrayTek routers support VLAN tagging on the WAN interface, as well as which is something often required by the NBN ISP in Australia, as well as some ISP in New Zealand. Right. So yeah, thank you for attending.